I see there's a couple of people coming, but I guess we can get started. So hi everyone, thanks for joining. I'm Adrien. I work at Google on a team called Android ML, and the ML stands for machine learning. So what we do is we try to make machine learning easier for Android developers mostly, and also for other apps, and also for the whole ecosystem. I know everyone's going crazy over large language models today, not the topic, so sorry about that. But there's some office hours happening 30 minutes after, so if you want to ask any questions not even related to that specific topic, but about ML on Android in general, I'll be available in another session. So today's topic is about running machine learning on device, and there are a few motivations where we want people to do machine learning on device. Some of them are if you are trying to run something that you want the user to get a feedback very quickly, and for example, some people do vision models on camera that may want to run at 30 frames a second. Sending the video to the server and then having the server process that and then sending the info back to the device will take a lot of latency. So like a lot of things will run a lot faster if you try to just run them on device instead of sending the whole data to the server, have it process it, and then send it back. Another very strong motivation for us, Google especially, despite what everyone's saying about us trying to collect way too much data, is that sometimes it also means that we can leave the data on the device. The data never has to leave the device. We do all the processing, and you still get the very good information that you would want without the data ever leaving the device. Also works offline. That's why it's pretty self-explanatory. And it can also save you costs in that we are working as a team at Google where they just realized that they were currently spending millions on like server costs, and that now on-device machine learning is good enough that they could just keep those millions altogether by just running things on device. So not giving names there, but yeah. So today, if you're an Android developer and want to benefit from machine learning for your applications, there are two main tracks you can use. The first one is MLKit, and this one is very much targeted at Android developers that don't know anything about machine learning. And those features are like features that are backed by machine learning, but you don't need to understand how they work. So for example, some of the features we have in MLKit are like things like barcode scanning, OCR, which is like reading text from an image, like even Google Translate. You can run that inside of your app if you want to translate messages from people in conversations or in threads or in articles or whatever. Image segmentation, like all of those are things that you can just use regular Android APIs to be able to interact with that. And we take care of all the machine learning below that for you. You don't have to understand any of that. If you want to get invested a bit more into doing your own thing, then that's where TensorFlow, and more specifically TensorFlow Lite, so the version that will run on device, will be relevant for you. So there too, we have two different options in that if you have a use case that is a use case that already exists and already has API for, so for example, you want to do like image segmentation or image classification or something like that, which are things that we already do in other things, but you want to provide your own model. So for example, we work with teams that, like third-party developers, for example, where they do things around sport, and they want to do like body segmentation, things like that, and they want to recognize specific like yoga poses or whatever. They may have their own model, but the use case itself is one that we already have. So in that case, you can use the regular API that we provide you, but you can just swap your own model there. And then if you want to do your whole thing all on your own, then you can, there's the interpreter API inside of TF Lite where you can have the full access to do that yourself. And that's pretty much like the way we expect everyone will do machine learning on Android. If they want to go deep, is they will do it through TF Lite. One of the things I wanted to mention for that too is that one of the things we've been working on that we have launched last year is that now you have a version of TF Lite inside of the Play services. And the two main reasons behind that was that one, we had like dozens of apps on the same phone that will have multiple copies of TF Lite, so wasting a lot of disk space. So we try to have one single version that's available to everyone. And the other thing that allows us to do is that we can now give you automatic updates for that thing, and that comes with bug fixes, performance improvements, and things like that. So we had a use case, not Lyft, but another ride-sharing app before, where they hadn't updated TF Lite in a while, and just getting the automatic updates gave them a 30% performance improvement just because they hadn't bothered doing that themselves. And now we can do that for all the Android users on, automatically. And that's currently running, like, as of today, like on virtually every device. So everyone in the room that has an Android phone has it. And it's running like trillions of sessions a day. And so we monitor it very closely that we don't break anyone when we actually do an update of that. So for today's specific topic, we wanted to discuss about hardware acceleration. And the basic idea behind our hardware acceleration is that a mobile phone is still just a phone, and it will never be as powerful as the hardware you can have on the server. But we want to be able to run things as quickly as you can on that specific device. And so by default, all the code you run is just going to use the CPU, so the central processing units, but you have other chips on your device that may be able to run the code faster for you. And so a lot of work from our team has been trying to make that easier for you to be able to benefit from this hardware without having to do all that work yourself. So the most common one that most of you probably already know exists is the GPU, so the graphical processing unit. And the basic idea behind that is that instead of being like a very powerful single-threading machine, like it's going to be a thing where you can run the same code on like thousands of pixels at once, and that's where you can parallelize massively the code. And for machine learning, you can do something similar, especially if you're doing image processing. So that can give you an idea about why that would be faster. Another chip that is like less common and something that most developers don't interact with ever is called the DSP, the digital signal processor. And that one is more like, for example, sound processing and things like that. So that would require like different hardware from a GPU, but those may also sometimes be beneficial for machine learning on device. And then the last one is something that's a fairly recent development, but now we have hardware manufacturers that are able to build chipsets that are designed specifically to run machine learning, and you start having those on devices too. So that has been around for like 2 to 3 years, something like that. And so we'll explain a bit about how you're supposed to run it with those. And so the benefits are, hopefully it will run faster. So one of the things to also understand is that it doesn't always run faster, and I'll explain a bit afterwards why. Another is that while you're not using the CPU, you can use the CPU for other things. And also, if you use hardware that is better suited for the use case that you have, it will also be better for the overall system health, in that it will be more battery efficient, your device will heat less, and so you will have better autonomy and things like that. So overall, most of those are things that will be better for the user because you will use dedicated hardware to run those exact computations. So how are you supposed to use it? So here we start getting into a bit of the crazy charts. But basically, you guys as Android developers would be at the top level, and then below that, you would have TensorFlow Lite, and then TensorFlow Lite itself will handle how you interact with those dedicated hardware, which are all the way at the bottom. And the way the interface between TF Lite and those things would be delegates. I'll explain just on the slide after that what those delegates are. And the idea that all of those are written like together, and the team like does all of those together, so they're compatible with one another. So you don't you shouldn't be spending too much time of trying to figure out like is version 2 of that thing with version 1 of that thing, and they're incompatible and those things. Like all of those like come from the same people at Google. So hopefully they should all work together. So the idea behind the delegates is that your machine learning model, like the representation inside of that, is a network of multiple nodes, and each node is a basic operation. And it's going to be like a matrix multiplication. It will be like a function that transforms the data with a specific shape or something like that. But it's just like a program represented as a graph. And what a delegate does, it does a pre-processing of your model, and it rewrites some of the nodes of your model and saying like, this operation that you were intending to do on the CPU, let me instead like replace the code for that with code that will invoke the GPU for you and will run that in the GPU for you. And so here, the idea was that you would start with a thing that's only for CPU, and all the TF Lite models by default are only designed for CPU, and then you run the delegate on that, and the delegate will rewrite the path that it thinks are relevant for the GPU, and then the model you have in RAM is something that will be a hybrid between CPU and GPU, and it will just run for you. So you don't need to write the delegate yourself. We have delegates for you. Some people, some crazy people can write their own custom delegates, not the topic of the talk, but basically that's what will happen. That you give a model, the model is only intended for CPU, and then we have code that will try to figure out which parts we can optimize for GPU. One of the other things it tries to do is that context switching between different hardwares means that you will have a lot of copy, you will need to pass a lot of data. So the delegate will also try to optimize that by trying to minimize those context switches, and sometimes even if one specific operation could be run on a dedicated hardware, the delegate will opt not to do that, and instead like just stay on the CPU, because it would be inefficient for you to do a context switch back and forth. the delegate will also try to optimize like, and try to change like huge blocks of the graph all at once, run all that thing on the GPU all at once, and then switch back to the CPU. So far, so good? Okay, so the most common one you will probably want to use, the GPU delegate, and that's a thing that we are now also making available through Play services. So again, you don't need to make your app much bigger. We're talking about megabytes, so it's not crazy, but still some nice size savings for those that are interested in that. And we will update that for you, so we'll get performance improvements. We will support new GPU hardware when those would become available. And one of the important things, the last one, which is that GPUs were not designed to run machine learning like 5 years ago. So the GPU delegate will not be compatible with all the devices. And so if you were trying to do that yourself, you may try to run it on devices where it would actually not work. And in our case, we try to maintain that and try to only give you the GPU delegate on devices where we expect it would actually work. So to give you rough orders of magnitude, we currently expect like it would be about 60% of devices where it would actually work. If you look at only flagships, you get like to 99.9% or something like that, like current flagships. So the numbers will get better over time, but it's going to take a few years for all people to update to devices where the GPU would be compatible with TF Lite. So we take care also of that for you, and I'll show you in the code afterwards how you're supposed to handle that. So speaking of code, like I said, so Play Services SDK, so that's just for the GPU SDK. You will also have other things like Play Services just for the Java API. We have exception service, which I'll explain a bit later. And things like that. So just a regular Gradle dependency. Then in your code, this is how you check whether this current device is actually able to run the GPU or not. So you invoke tflite GPU.isGPU delegate available, and that will return to you a Boolean of whether this device will actually run it or not. Now, this is the code that you would have if you were not trying to do anything GPU. So just the basic tflite code, the interpreter API, that you create an interpreter, and then you will invoke, you will give it some input and output later on. Now, if you want to support hardware accession for that, like I said, first you have to check whether you would actually be able to use the GPU. But then, if the GPU is available, while you're creating your interpreter, you add a delegate factory to it in the options, and that's all you need to do. Then, when you will give it the model in the line that's after that, then the model will be rewritten by the delegate, and that will make it GPU compatible. And that's what the whole code looks like. So hopefully not too scary for people. Now, I did mention that there are other hardware than the GPU. So there was a solution that had been around for, I think, 4 or 5 years now, which was NN API. So NN here stands for neural networks. And that one is a bit different because that one is part of the Android framework itself. So that one was only available on recent versions of Android. I think it's API level 19, if I remember correctly. And then that means you only get bug fixes and improvements as you get newer versions of Android. So that's also something we're trying to be better at that. But currently, I would recommend using the GPU delegate first. An API is still a thing that you can try to use, but you wouldn't get the benefits as mentioned. You would have to deal a bit with OS fragmentation and things like that. And that's something we're working on making better eventually. And so one of the other things we're doing that, like I was saying, currently we have about 60% of the GPUs that are compatible, but we're trying to also work with the manufacturers to actually have them give us drivers and try to make those work for future versions. Another thing we've been working on is something called the action service. So one of the challenges is that I did mention sometimes the GPU will not actually be faster because maybe the context switchings are too much, or maybe your model, for example, language models don't necessarily would benefit from the hardware that well. Vision models definitely would benefit from GPU a lot, but other structures of models may not definitely do that. And so that would not always work. And like I said, we also have some hardware fragmentation, driver fragmentation, Android OS versions fragmentation. So all of those are things where you would not always be able to support them. So one of the things we've been working, and that will be released very, very soon, is the accession service. So currently we're running an early access program, and that one has been successful, so we'll go to beta very soon. So the idea is that you can, if you don't want to restrict yourselves to the allotments we have for GPU, you can run your own tests. And so the idea that you give us your model, you give us some samples where you say, this is the input I want to test, and this is the output I expect to have. And you can also give us some metrics about the accuracy or about how long you expect that to run. And the idea that we will take all those data inputs and we will run the test for you. And we will run that in the background. There will be no disruption to the user, and we will return to you a result telling you whether we actually think that this device is compatible with your case or not. So this is an advanced use case. In the default use case, you just use GPU delegate and you trust us for to do the thing. But if you think you can actually go further than that, or if you want something that can also measure the latency or measure the accuracy, and you want to have finer grained control of that, we can also handle some of that for you. And part of the challenge is that because that one would actually not necessarily respect the alert list, if you get that wrong, you may crash the device or something like that. And the reason to use the extra service would be that we would handle that for you, and we would try and prevent you from disrupting the device's user. So that will come live very soon. So overall summary, start with ML kits if you just want to benefit from powerful features without having any ML experience. Then, if you start digging into things, you use TF Lite, you use Interpreter API, and you want your things to run faster. So, for example, if you're on a vision model and you want to run the camera at 30 frames a second or something like that, then that's probably the right time for you to start looking at hardware acceleration. First thing I would suggest you look at is just use the code snippet I showed you earlier, where on devices that can run it, you enable the GPU delegates, and then that will run things on the GPU. And then if you want to go much further than that, then we'll have very soon the extraction service API that will allow you to actually run very fine-grained control about whether you think that running on a hardware will be good for your experience or your feature or something like that. And the extraction service will also be compatible with other use cases like DSPs and TPUs. So yeah, that was the main thing I wanted to mention. We do have office hours available right after the break, so there's going to be a 15-minute break after this session. But I'm happy to answer any questions people may have now if there's still time. Cool. There's some questions. I think there's microphones.
Thank you very much for interesting talk. Quite interesting topic, especially for my company. We are using intensively AR core technology, and now we are faced with problems that we are going to make a France ML kit and AR core. And is it a good idea? I mean, we need a functionality to use OCR technology while our AR session is running. What would you recommend? Use directly TensorFlow Lite, or we still have opportunity to use together machine ML learn ML kit and AR core?
I would always recommend trying ML kit first, just to see if it fits your needs, because actually testing ML kit would be done in a few hours. So you would get a very short feedback loop, again, very regular Android APIs. So you would be able to prototype something, and they also have samples that are very good. So you would be able to know very quickly if it actually fits what you want to do with it or not. And then if you think that ML kit is not enough for your use case, then you can start digging into TF Lite, something like that. That answer your question?
Probably yes, maybe small addition.
Sure.
Is it possible to share a video stream between AR session and ML?
That's a good question. I think no, MLKit would handle the camera for you, so you may not be able to give the camera flux directly. I'll have to check on that, but indeed, yeah.
Okay, thank you.
Sure, happy to. Yeah.
Thank you for the presentation. Does the acceleration API rely on server, or does it need internet connection to work?
So it works completely offline. It will run, so that means on every device where you try to run the sample, it will do that. We also have some experiments that we run on devices distributed, and we use that to avoid running the same test on multiple devices that are virtually identical. So all of those would still work offline, but us having a network connection sometimes allows us to skip some of those tests, not for extraction service specifically, but for others that we do. But all of those by baseline would work offline. So the whole goal for that is we do want people to do on-device machine learning to be able to work offline, all of those. So we never want people to be blocked by not having internet. So we want the devices to have like once a quarter access to internet so they can get updates. But outside of that, everything should work offline.
Thank you.
Happy to. Okay, that can be it then. Like I said, office hours after the break, if you want to discuss that into more details. Thank you.